Right, Nana? So is it audible, right? Right. So last class we discussed buffer solutions, right? So in case of soluble salt hydrolysis, the pH calculations, normally pH is equals to minus log, hello, H plus ion concentration. Yes or no? Otherwise, we can write H plus ion concentration is equals to water 10 to the power of minus pH. So these two formulas are very important. And at 25 degree centigrade, pH plus pOH is equals to 14. pH for weak as salt of weak acid plus strong base, right? What is the pH? Hmm. Hmm. So pH is equals to 7 plus pKa plus log C, right? This is for salt for weak acid, strong base. So like CH3, COO, Na, that cases. KH value for this one, no? KH, Kw by Ka. What is H? Under root of Kw by Ka into C. Right? For weak acids, so this is what? Salt of weak acid, strong base. So pH for salt of, right, strong acid plus weak base. So KH is equals to Kw by Kb. H is equals to under root Kw by Kb into C. Right? What about the pH? pH is equals to 7 minus 1 by 2 pKb plus log C. See now, the difference between here is 7 plus 7. In case of pKb minus 1 by 2, pKb plus log C, it is plus. So only the difference is plus and minus. Right? So, and pH for salt of weak acid plus weak base. Come on, let me know. 7 plus 1 by 2 pKa minus pKb. Right? So generally for weak acids, so here is the KH is equals to what? KH is equals to Kw by Ka into Kb. H under root KH means this is opposite direction. So these are the things which we discussed this one. And in case of pH of buffer solutions, pH is equals to pKa plus log salt concentration by acid concentration, not base. pOH is equals to pKb plus log salt concentration by base concentration. Acidic buffers and basic buffers, two types of buffers are there, right? So for weak acids, Nana, for CH3 COOH gives rise to CH3 COO minus H plus C dash dash C minus C alpha C alpha C alpha. H plus ion concentration is nothing but C alpha. For weak acids C alpha, we need to know the alpha value. So if concentration and alpha, if we know, then we can calculate the pH for weak acids. What is alpha? Alpha is equals to C into under root Ka by C. So H plus ion concentration is equals to under root Ka into C. Under root Ka into C. So OH minus ion concentration for weak bases, for example NH4OH, right? OH minus ion concentration is equals to under root Kb into C. When the Ka and Kb is given, so that we need to understand those are weak. So those are weak. For example, HCl plus NaOH, both concentration is given. For example, this is 200 ml into 0.1 molar. This is 300 ml into 0.2 molar. So is there. What is its pH? Come on, do it, this calculation. 0.1 molar. So we'll do in the next page. Is a mixture now. The mixture acid plus both are there. What is its pH? Come on, do the calculation. Come on, do it. అందుకోసం అది ఇచ్చింది. రైట్ రా చేశారా? మేఘన వచ్చింది ఆన్సర్? pH what I'm asking. ఎట్లా చేస్తాం? అసలు నీకు అది స్ట్రాంగ్ యాసిడా వీక్ యాసిడా కేఏ దేనికి వస్తుంది? మరి అదేంటి అవి ఏం యాసిడ్ అది? అవును మరి నువ్వు అడిగినందుకు నువ్వు అడుగుతుంటే నేను ఏం చెప్పాలో తెలియక నీకు చెప్పలేదు. నీకు ఇప్పుడు స్ట్రాంగ్ యాసిడ్ కేఏ ఎందుకు వస్తుంది చెప్పు? 100% డిసోసియేట్ అయిపోద్ది కదా, మరి ఎందుకు అడుగుతున్నావు మొత్తం విన్నాక? అవునా కదా? అసలు కేఏ అని ఉండదు, 100% డిసోసియేషన్ అయిపోతుంది. ఆ స్ట్రాంగ్ యాసిడ్ స్ట్రాంగ్ బేస్. కేఏ ఎందుకు వస్తుంది అసలు నీకు? కేఏ ఎప్పుడు వస్తుంది? కేఏ ఎప్పుడు వీక్ యాసిడ్? ఇక్కడ వీక్ యాసిడ్ ఏమైనా ఉందా? మీకు లిస్ట్ ఇచ్చాను కదా, వీక్ యాసిడ్ ఏంటి స్ట్రాంగ్ యాసిడ్ ఏంటి. ఇది వీక్ యాసిడ్, ఇది 100% కాదు. CH3CO మైనస్ H ప్లస్ అండ్ కాన్సన్ట్రేషన్ వస్తుంది. అప్పుడు C డాష్ డాష్ C మైనస్ C ఆల్ఫా C ఆల్ఫా H ప్లస్ అండ్ కాన్సన్ట్రేషన్ అప్పుడు √KA ఇంటూ C. pH is equals to minus log H plus and concentration. ఇది దీనికి రైట్. అసలు హైడ్రోలిసిస్ అవ్వదు, న్యూట్రలైజేషన్ అయిపోతుంది అది. అవును వస్తుంది. అదే కదా క్వశ్చన్, అందుకోసం కదా ఇచ్చింది. సోనా నీకు వచ్చిందా? సోనా, ఇషా, మిల్లీమోల్స్ ఎన్ని మిల్లీమోల్స్ ఉంటాయి? 0.1 ఇంటూ 200 ఎంత? HCl plus NaOH gives rise to NaCl plus H2O, right? So millimoles is equals to direct రాస్తాను, millimoles equals to molarity into V in ml, right? 0.1 into 200 ఎన్నిరా? 20 millimoles ఇది, రైట్. ఇది ఎంత? 0.2 into 300 ఎన్ని వస్తుంది? 60 millimoles వస్తుంది. 60 millimoles. ఇప్పుడు ఏమవుతుంది మనకి? రిజల్టెంట్ సొల్యూషన్ ఏముంటుందిరా? ఆఫ్టర్ ద టైం 0 ఉంటుంది. ఇది ఎంత ఉంటుంది? ఇందులో 20 ఇందులో 20 వెళ్ళిపోతే ఇందులో 40 మిల్లీ. ఇవి 20 అవి ఫామ్ అయిపోతాయి, రైట్? 40 మిల్లీమోల్స్. 40 మిల్లీమోల్స్ అంటే ఏంటి? మనకు OH మైనస్ కాన్సన్ట్రేషన్ వస్తుంది. OH మైనస్ కాన్సన్ట్రేషన్ నుంచి POH వస్తుంది. POH నుంచి pH క్యాలిక్యులేట్. ఓకే, అర్థమైందా? సో ఒకవేళ రెండు ఈక్వల్గా ఉన్నాయనుకోండి, అప్పుడు ఏమవ్వదు, న్యూట్రల్ అయిపోతుంది, 7 వస్తుంది. మేఘన వస్తుందా? sorry. Isara? OH minus and concentration is equals to what? So millimoles by total volume is how much? Total volume 200 into 500. So OH minus and concentration will get 0.08. 0.08. So now calculate the POH. POH is equals to minus log OH minus ion concentration. So minus log 0.08. So we'll get approximately 1.10 POH. So if we get the POH is 1.10, pH is equals to 14 minus 1.10. 12.9. So approximately we'll get 12.9. Okay. Got it? When strong acid and strong base. So don't try to do one more question. Same this type of only. For example, HCl only. I'm just giving you 0.2 molar 300 ml. Right? Plus NaOH is 0.2 molar 200 ml. So calculate its pH. Calculate its pH. Come on, do it fast. Online చూస్తున్నారు ఎవరన్నా? అట్లే వస్తుంది. వేగన వచ్చిందా? సోనా, ఇషా, వస్తుంది. ఎంత వస్తుంది ఇక్కడ? 0.60 ml, 60 millimoles, right? 60, 40, 40, 40, 20, 20 by 500, 0.04, 2 minus 0.6 ఎంత వస్తుంది? ఇంకా చేస్తున్నాము. రైట్ రా, వచ్చిందా? నెక్స్ట్ అన్న సాల్యుబిలిటీ ప్రోడక్ట్. KSP అంటాం, సాల్యుబిలిటీ ప్రోడక్ట్. Solubility, because solubility means saturated solutions, unsaturated, super saturated. Okay, saturated, unsaturated, super saturated. So here is put the headings: solubility. So saturated solutions, write it down. The maximum amount of solute that can be dissolved in a specific amount of solvent at specified temperature to form a saturated solution. So that we are called as solubility, units mole per liter. Write it down. The maximum amount of solute that can be dissolved in a specified amount of solvent. In a specified amount of solvent. Which were called as solubility. Right? So classification of salts. So category 1 soluble. Solubility is greater than 0.1 molar. So category 2 slightly soluble salt. So these are 0.01 molar to, so in between 0.1 molar. So sparingly soluble salts now. So solubility is right, less than 0.01 molar. So write this table. So solubility is greater than 0.1, this is right soluble, slightly soluble, sparingly soluble. In the solubility product we will discuss this is sparingly soluble salts. So write it down. Then completed. Hello. Right, solubility. So equilibrium is established between, for example, BaSO4, sparingly soluble salts, right? So consider the BaSO4 is a sparingly soluble salts, means 100% soluble is not per. Some solid plus liquid, when we are adding this Ba2 plus SO4 2 minus, right? These ions are forming and they are forming with the equilibrium with this salt. So write it down. So actually solubility product we were discussing, but this is right, left to right is dissolution and right to left precipitation. Dissolution and precipitation. The equilibrium is established between the undissolved salt and its ion. Chandra? So here we have different types of AB type, AB2, AB3, A2, B3 types. We'll discuss that. So for example, BaSO4S2, Ba2 plus SO4 2 minus. So K equilibrium. How can we write? Ba2 plus concentration by SO4, Ba2 plus and SO4 2 minus by BaSO4. K equilibrium is a constant because sparingly soluble salts, right? Write it down there. BaSO4 so this one almost all we can take the solubility product now. So this K nothing but solubility KSP. So KSP experimental value 1.5 into 10 to the power of minus 9. Because these almost all these two are constants, right? These two are constants, right? This we are called as KSP. KSP is nothing but solubility product. So experimentally this value is 1.5 into 10 to the power of minus 9. Solubility product value. Write it down. Done. So here is solubility product nothing but KSP. The product of molar concentration of ions in saturated solution raised to power equals to the coefficient of the ion, right? Ksp depends on only the temperature at a particular salt. So 2 points are very important, just write it down. Ksp, product of, for example, imagine AB type, AB type, AA plus B minus. Ksp is equals to concentration of A plus into concentration of B minus ion. So this is the definition is the product means in the multiplication, the product of molar concentrations. When we are writing the brackets in the molar concentrations ion saturated solution rise to the power of equal to coefficients of the ion. For example, we'll discuss, for example, AB2. AB2 means what? 2A plus A2 plus, sorry. A2 plus 2B minus. So how can we write now Ksp? A2 power plus 2B power minus square. So Ksp depends only on temperature. Of course, I'll discuss those. The product of molar concentrations of ions in a saturated solution rise to a power of equals to its coefficient. Rise to a power equal to the coefficient of ion. Done? For example, write like this, AB type, of course solid, after hydrolysis A plus plus B minus, solubility SS, solubility. I am taking the SS. So now Ksp is equals to S into S. This is nothing but S square. Okay. S means what? Solubility, Nana. S is equals to what? Right, under root of Ksp. Write it down. This is AB type of salts. AB type of salts. Imagine AB2. A2 plus 2B minus, nothing but S, 2S. What is Ksp? Ksp is equals to S into 2S whole square. Right? S into 4S square. Nothing but 4S cube. Ksp is equals to S is equals to cube root of Ksp by 4. Hence S cube is equals to Ksp by 4. S cube is equals to cube root. AB2. Next, AB3 type. AB3 type. A3 plus 3 B minus is S 3S. KSP is equals to S into 3S cube. S into 27 S cube. 27 S power 4. S is equals to KSP by 27 cube. Next, A2B3 type. Next, 2A 3 plus 3B 2 minus means 2S 3S. KSP is equals to 2S whole square into 3S whole cube. 4S square into 27 S cube. Nothing but 27 into 4, 108. Right? KSP is equals to 108 S power 5. S is equals to KSP by 108. Right. So this is the way which we need to do. AB, AB2, AB3, A2, B3. So AX, BY type also we can take the same thing. Come on, write it down. Done, Anna. So mx y, so actually x, right? So charge run. So just ax by type. So it's no need to calculate. So it's somewhat given wrong. Ionic product, Nana. So here is ionic product and solubility product. Two things are there. So KIP, ionic product, write it down. For a solution of salt of specific concentration, so the product of concentration of ions, each ion rises to power equal to their coefficient of the ions. Ionic product and solubility product. Write it down, KIP. Specific concentration, for a solution of a salt of specific concentration, the product of concentration of the ions, each rise to power of equal to their coefficient ions. Solubility product and ionic product both are important. Based on that, we can say, so how, whether it is soluble or not, we'll discuss that. Done. See, no. So solubility product and ionic product applicable only saturated solutions. So applicable saturated as well as unsaturated solutions. Which one? Ionic product. So measure that maximum amount of ions that can be solution can be dissolved. So right, measures at actual amount of ions that is present in the solution. The difference, write it down. Solubility product and ionic product. That is saturated as well as unsaturated. Solubility product versus ionic product. Done or now? Right now. So if ionic product is less than solubility product, solution at unsaturated level now. So more salt can be dissolved, so no precipitate is formed. When there's more solubility product, so this is very, very important, then keep on asking the questions based on this. What is solubility product and ionic product cases? The solubility product is more, solution, the solution is unsaturated, means more salt can dissolve, no precipitation formed. Then both are equal, right? So solution will become saturated, no precipitation, of course. Very important. The relationship is case ionic product and solubility product. Then next one. If ionic product is greater than solubility product, solution is holding more salt, right? That can be dissolved. So means precipitation takes place. When the precipitation takes place, ionic product is greater than solubility product. Very important. Very, very important. Write it down. Then done. See, no. So saturated solution, KSP, ionic product and solubility product. So a precipitation occurs when ionic product is more. So if you want, you can write this diagram. Done? Solubility, right? In the presence of common ion, presence of common ion, what exactly in the solution decreases the solubility to a given sparingly soluble salt. Write it down. Effect of common ion on the solubility of sparingly soluble salt. Presence of a common ion in the solution decreases the photo. Done. So this is of course same like equilibrium problems. Soluble salts. So KSP, no issues. Right now, so effect of pH of its solubility, lower pH, right? Lower pH solubility of salts of weak acids like phosphates increases. So at low pH, anions are decreases due to protonation. Solubility of salt is increases. Write it down. At low pH, solubility salt of weak acid like phosphates. Chandra. So even name అవసరం లేదురా, directly we can do. ఏం అవసరం లేదులేండి. Right now, so this is about the ionic equilibrium. Almost all we did. So chemical equilibrium and ionic equilibrium, so we discussed in a detailed mode. And now your job is go through the NCERT, right? NCERT textbook, solve the in-text questions and backside questions. In-text as well as backside questions, solve it each and every question. So any particular doubts, let me know. So I'll discuss that one now. So the next chapter, whether I'll discuss thermodynamics, otherwise atomic structure in this too. Okay. So meanwhile, just go through the NCERT and PYQs, right? PYQs, previous year questions. So just go and solve it. Any doubts, just take the picture and send me in WhatsApp. Okay, Nana.